Hello everybody to a new video and welcome to Unit 4 of the ROS in 5 days course. Today we are going to be talking about ROS actions and we are going to see part 1 of this Unit 4. So what are you going to learn with this unit? We are going to learn what is a ROS action, how to manage the different actions in a robot, and how to call an action server. So yeah, let's start. First of all, here you can see a drone. It is a Parrot Drone simulation, and well, you can interact with this drone by issuing these commands you can see here. For instance, let's try this one here, which will take off the drone if we execute it. There it is. As you can see, we execute the command and the drone takes off. You can also move the drone around by using this command here. Let's try it. There it is. Now by using the keyboard we can manage the drone and you can fly it around. Yes. And finally we have as well another command to land the drone again. So let's try it as well. And there we are. We have landed the drone. Excellent. So yeah, here you have some commands that will allow you to play a little bit with the simulation, with the drone, fly it around and do whatever you want. So yeah, let's start with the unit itself. So what are actions? As I already told you in the previous unit, in services, we have a preview of actions. An action is basically the same as a service because it provides a functionality when you call it. Yes, the same as a service. So with a service you have a functionality that you can call, it will do something and then it will return to you a result. Yes, then an action, it is also providing a functionality exactly as a service, but what's the difference then with a service? The difference between an action and a service is that when you call a service, you have to wait until the functionality and whatever the service has to do finishes in order to continue with your program. In an action, when you call an action, you can still do things while the action is being executed. Yes? So, for instance, let's say we have a service that moves the drone making a circle. Yes? It does a circle, and when it returns to the starting position, it stops. Yes? So, when I call the service, the drone will start moving, doing a circle, and it will stop at the initial point. Yes? Then, if I do this with a service, when I call the service, I will have to wait until the robot does the full movement and it stops in order to continue with the program. Yes? So while the service is being executed, I cannot do anything else. Yes? I have to wait until that service finishes. If instead of a service I use an action for this, when I call the action, the robot will start moving, doing this circle movement, but while it is doing this movement, it can do other things. For instance, it can take pictures of the environment, let's say. Yes? So I don't have to wait until the action finishes in order to continue doing things. Yes? I can do other things while the action is taking place, is being executed. Yes? Excellent. So let's make the notebook bigger. Yeah? Yeah, so here, so this means that actions are asynchronous, while services are synchronous. Yes? This is the difference. Synchronous, service is synchronous, and an action is asynchronous. Yes? Then actions, we can divide actions in two parts, let's say. The server, which is called the action server, and the client, which is called the action client. Yes? Then the server, the action server, allows other nodes to call that functionality. So the action server is the part of the action that contains the functionality. Yes? It's where you will code what that action will do, what functionality that action will provide. Yes? So for instance, if it is to move the drone, you will code that in the action server. So in the action server is where you will find the functionality of the action. Then the action client is the part that allows to call that functionality. So the action client will call the action server in order to use the functionality that action provides. So this is similar than services. In services, if you remember, we also had a client and a server. The client was to call the server, and in the service server we had the functionality of that service. Yes. So this is very similar with actions. We have the action client, which is the part that calls requests that functionality, and we have the action server, which is the part that provides the functionality. And then here we have some things connecting both parts that we are going to see while we advance through the unit. Then let's begin doing some exercises or examples, because, well, they are guided, so it's like a guided exercise in order to see a little bit how an action works, to begin to work with actions. So the first thing we are going to do is to execute this ROS launch command here. Yes, there we are, ROS launch rdrone as ActionServer.launch. So we are going to execute this command here. Basically, what this command does is to start the action, to make it available for anyone to call it. So it is starting, let's say, the action server, because now with this command I am starting the action server, so I am making the functionality available for anyone to call it. Then, if you remember from previous units, if I wanted to look for a topic, I used the ROS topic list command, right? This was the command I used in order to check for the topics that are available in this simulation. Then in services, in order to check for the available services, we used the ROS service list command. Do you remember? So we had ROS topic list in order to look for topics, and ROS service list in order to look for services. So I ask you, what is the command in order to look for an action? Think a little bit. I'm quite sure that you are thinking of this command, ROS action list, right? Well, let's see. And no, this command doesn't exist. We cannot look for an action using the ROS action list command. So how do we look for an action? Well, it's using the ROS topic list command. Yes, the same command used in order to look for topics. Okay, but then if these are topics, because you have learned in the topics unit that the ROS topic list command prints topics, so if I'm here seeing topics, how can I know what is an action? Okay, well, you have to look for this structure. For instance, in this case, we have a common namespace, let's say, which is rdrone ActionServer. And we have a cancel, feedback, goal, result, and the status. 5 different topics for the same namespace. So let's have a look at the topics in this simulation in order to see if we can find something similar to this. And there we are. So here I can see data structure. I have the ArtDrone action server in common in 5 different topics, which end with cancel, feedback, goal, result, and status. So what is this? This is telling me that there is here an action. So here there is an action that is called ArtDrone action servers. And how can I know this? Because I can see this structure. 5 different topics, one for cancel, feedback, goal, result, and the status. And all of them share a common namespace. Yes, you see this? So always you see a structure like this one with these 5 topics. The cancel, feedback, goal, and result, and the status will always be the same. Of course, this namespace can change depending on what's the name of the action. But this structure, every time you see this structure in the list of topics, this means that there is an action here. Yes? Understood? Okay, so let's continue, yeah? Here we are. So we have, this means that ArtDrone action server, as I was telling you, ArtDrone action server is the name of the action server. And cancel, feedback, goal, result, and the status are the messages used in order to, are the topics, let's say, used in order to communicate with the action server. We will see later what is the purpose of each of these topics. Yes? But basically, you have to know that this structure means action server. Alright? Excellent, so let's continue. Then, how can we call an action server? Well, it's quite simple. If you remember, in services we had the ROS service. Let's put it here. For services we had this ROS service call whatever function. Yeah? But for actions, I am working with topics. So the way I will call an action server will be by sending a message for a topic to that action server. So if I want to call an action server, what I will do is to send a message through a topic, through this topic, we will see it later, but it's through this topic I will send a message to the action server. And that will activate the action server and will begin to do whatever it has to do. Yes? So it works by sending a message, as always. In topics we communicate through messages, in service we communicate through service messages. In actions we also communicate using messages, but the messages that action use are different. So let's do a quick exercise in order to check this. So we are going to, okay, let's go to this ROS-cd ArtDrone IAS action directory, and here I will do, okay, cat ArtDrone action. Here we have it. Yes? So this is the message that defines the action. In this case, the ArtDrone action server action that we saw previously. So this is the message that defines this action. And as you can see, it contains 3 parts. So if you remember from previous units, the messages we used for topics had only 1 part. Yes? The messages we used in services had 2 parts. They contained the request and the response. Do you remember that? But now in actions we add another field yet. So we have 1 part of the message, the first part of the message, which defines the goal. We have separated but by these three lines, separated by these 3 lines, we have the second part of the message, which is the result, which defines the result of the action. And finally, after another 3 lines, which are used, as you learned from services, to divide the message. So after these 3 lines, we have the third part of the message, which is the feedback of the message. So we can say, trying to make a comparison with services, we can say that this first part of the message will be the request. In this case, it's called goal. But it is the part that defines how we will call the action server. So how we will communicate with the action server, how we will call it in order to start it. Yes, this is defined in the goal in the first part of the message. Then in the second part of the message, we define the result, which is what the action server will return to us when it finishes. This is similar to the request in services. Then, finally, what is this feedback part of the message? Well, actions also have a very nice feature, which is this feedback. Because actions, while are being executed, they can provide feedback. For instance, to say how it is going, the action. I am doing fine. I have taken 2 photos so far. I have taken 3 photos so far. So while the action is being executed, it can provide feedback to the user. Yes? And this is defined in the feedback section of the message, in the third part of the message. Okay? Well, yes. Yeah, you have it also here explained. I know there is a lot of new information. I know some of you may get lost, but don't worry, because while we advance through the unit and while you begin practicing doing exercises, I'm sure everything will make more sense. But now I know there's a lot of new information and it may be a little bit difficult, okay? But don't worry, be patient. So, yeah, that's it. So the messages that we use for actions have 3 parts. Remember, in topics they had just 1 part. In services they had 2 parts, the request and the response. Now in actions the messages have 3 parts, the goal, the result, and the feedback. Okay? And yeah, actions, as I've just said, provide feedback. So they can send messages while they are being executed in order to provide feedback of how it is going, the action, what is it doing, whatever you want. You can define yourself the feedback you want your action to provide. So that's up to you. But actions provide feedback. In services, this is something you couldn't do. You had to wait until the service finished and get a response at the end. But you don't know anything while the service is being executed. In actions, you can provide feedback while the action is being executed. Okay? Excellent. So let's see how to call an action server. We are going to see how to call it using code now. Yes, later we are going to see how we can call it using other methods. But we are going to see how to call an action server using code, which is by executing the code for an action client. Yes, so this is the code of an action client. This will call the action server. In this case, the action server, we've launched it here. If you remember, we have here in this launch file, we have launched the action server. And now, by using this code, by executing this code, we are going to call that action server. Yes? This, if you want, it's similar to services. So you had the service server and you had the service client, and you also saw in the previous unit how was the code for a service client. Yes, so this is the code in this case for an action client. So let's execute it and see what happens. Okay, yeah, it's this exercise here. Execute the following Python code. Remember that you have to have the ROS launch RDroneIS action server running. We have it running here. If you don't have this ROS launch running, this won't work, obviously, because you can't call an action that is not started, that is not running. Yes, so here we have launched the action server, and that's why we can call it. If we don't launch the action server, we cannot call it. Yeah, that's quite obvious. So excellent. Yeah, let's try. Let's execute this piece of code and see what happens. We are going to analyze it later. But yeah, let's try it. There we are. As you can see, here I'm visualizing the feedback. Yes, I'm getting feedback. Image number 1 received, image number 2 received, image number 3 received, etc. until the result, which is state 3. We are going to see now what this means. Yes? But as you can see, now the functionality of the action has finished, yes? But while the action was taking place, I was getting feedback messages. And then at the end, when the action has finished, I get the result message. Yes? So, great. Let's have a look at the code in order to better see how this works and what it does internally. Yes, so let's see. Yeah, here we are importing some modules that we will need, ROSPy, time, and ActionLib. Here we are importing the messages related to this action. Yes, so from the RDroneIS package, message directory, we are importing these messages: RDrone action, RDrone goal, RDrone result, and RDrone feedback. Okay, then here we are defining a callback for the feedback. So this is the feedback callback. In this case, what I am doing is to print the nImage variable, yes, which is the one which is a global variable that I can access whenever I want. So in this feedback, what I'm doing is to print a message saying which image has been received. Yes, it's very simple feedback, as you can see. So whenever feedback is received from the action server, this feedback callback will be called. Yes? Then, as you can see, we initiate the node, as we always do when we create a ROS program. Then we create the connection to the action server, which is called RDrone Action Server. Yeah, you remember, we saw it using the ROS topic list command here, up. Here we have it, the RDrone Action Server. Yes, so we create the connection to the RDrone Action Server. We state the message that this action server uses. Then we wait for server. We check if this action server is running, is up and running, is available. Then we create a goal variable. We fill this variable with the value. In this case, it's the number 10, as you can see. Yes. It goes until 9 in this case, but it's 10. It indicates take pictures around 10 seconds in this case. Yes. Then then finally we send the goal. We send the goal to the action server, and we define the feedback callback function, which in this case is feedback callback. It's this one here. Yes? So we send the goal to the action server, and we wait for the result. So we wait until the action server finishes and returns the result. So as you can see, it's quite simple. It has, yeah, it's not that hard. Yeah, we have a little bit more of code than in services, than in topics, but if you analyze line by line, it's not that hard. Yes? Excellent. So yeah, here we have an explanation a little bit more deep of the code. Excellent. So yeah, in this case, so until now, we know how to call an action. Yes, but until now, here in this code, for instance, in this action client, we are waiting for the result. So we wait until the action ends in order to get the result. Yeah. So in practice, this is the same as a service. We have the feedback, yes, but this is almost the same as a service. Yes. So how can I perform other tasks while the action is in progress? Yes, which is the main functionality that actions give us. Yes. How can we do this? Okay, so for that, actions basically provide two functions. One is the wait for result, which is this one we have seen here. Yes, this function waits until the action finishes, and when the action finishes, it returns a true value always. Yes. So in this case, this function is like using a service, because it will wait until the action finishes, and that's all. So you cannot do anything else. You cannot do other work while the action is taking place. Yes. So this wait for result function is like using a service. Yes. But we have another function, which is this getState function, that we can call in an action client, and which is very interesting, because while the action is taking place, we can call this function, and it will return a value 0, 1, 2, 3, 4, depending on in which state is the action. So for instance, pending, active, done when it finishes. Yes. So pending is before it starts, active is while it's taking place the action, done is when the action finishes. Finally, you have warning and error, in case it returns an error or a warning. Yes. But for instance, we can check the value of this getState function, and while it is lower than 2, it means that the action is still taking place, and we can check this and we can do stuff. Yes? So you can create a loop. Yes, you can create a while loop that checks if the value returned by the getState function is 2 or higher. Yes? Then if it is not, if it is lower, it means that the action is still in progress. It is in pending or active. Probably it will be inactive. Yes? So you can keep doing other things. Okay, so let's see an example of how this will be done with code. Yes, because talking maybe it's a little bit hard to understand. Yes, so let's check it in code. Yes, here we have two examples of code. One, it uses the client wait for result function, and the other one, it uses this getState function for checking the value of the state of the action. Yes, we have it here. Yeah, you can see it here. So let's execute these two pieces of code and see what are the differences. I'm going to first execute this one. So I'm going to restart the kernel. And now I'm going to execute this piece of code. There we are getting the feedback. And there we are. So nothing new here. We have received the feedback, but it has never entered here. Yes? So here we have a log which says doing stuff while waiting for the service to give a result. But this is not shown because the program never entered this while loop. Because what this function does, as I told you before, is to wait until the action finishes, and when it finishes it returns a true, sorry. Yes, so this condition will never be true. Yes, so this is useless. So if you want to do other stuff while the action is taking place, you won't use this wait for result function. Yes, so this is clear. Now, how to do it correctly? Okay, so let's restart again the notebook and see what happens if I execute this piece of code here. Let's execute it. Okay, so I'm getting the feedback, and meanwhile I'm getting the feedback, I can see other logs, yes, saying this state result 1 and doing stuff while waiting for the service to give a result. Yes, so the state here is 1, which means active. Active means that the action is being executed. Yes, so while the state value is 1, I can do other stuff. Yes, so this is what is being done here, exactly here. While a state result is less than done, is less than 2, while the state result is, as you can see, it's defined here with the getState function we saw previously, yes? So while the state result is less than done, so while the action has not finished, I can do other stuff. In this case, I have I'm printing a log, but here I can put whatever I want. Yeah, so this is the key. Here I can put whatever I want. I can do other things while the action is taking place. Yes? So yeah, this is very clarifying. You can see the difference between this code and this one, and how in this one you can use this getState function in order to do stuff while the action is taking place. Excellent. So let's move on, and now it's time to do an exercise. This exercise 4.6, you have to do it alone, yes, because this is not a guided exercise like the ones we have been doing until now. And what you will have to do, you have to create a package that contains and launches the action client from exercise 4.4a. 4.4a is this one. Yes? No, this. Yeah, here we have it. But here we have an example of action client. But you can take any of these ones. Yes, the one that you prefer. Yeah. So create a package that will contain and launch an action client. Yes. You have seen various examples of action clients. You decide which one you want to take. So create a package that contains and launch an action client code. Then within that code, you have to modify it a little bit and add some code that makes the quadcopter move around while the action server has been called, while the action server is taking place, is being executed. Yes? So while the action server is taking place, you will have to do other stuff. In this case, move the drone around. Okay, so this is very similar to what we have been talking right now. You remember, with the getState function, creating a while less than done. Yes, you remember? So it goes more or less this way. So you have to add, modify a little bit the code in order to make the quadcopter move around the environment while the action server is taking place. Then stop the movement when the last picture has been taken. So when the action server has finished, you stop the drone. Yes? So while the action server is taking place, is basically this, the active state 1. And the action finishes here, in the value 2, done. Okay? This is important, you know it. So yeah, that's it. So create a package that will launch an ActionClient code. Then you have to modify a little bit that code in order to move the drone while the action server is taking place. And when the action server finishes, you will stop the drone. Okay? So that's the exercise I want you to do. You can stop here the video if you want in order to do the exercise, whatever. I will keep going with the explanation, yes? But you can do whatever you want. You can pause, whatever you want. In case, I highly I highly recommend you, suggest you to try to do the exercise by yourself, yes? Even if it takes a lot of time, even if you think it's very hard, try it, yes? And then you can check here the solutions, a possible solution to this exercise, yes? If you are very stuck and you don't know at all how to proceed, how to continue, you can check the code of the solutions in order to see how it can be done, okay? But I highly recommend you to try it by yourself without looking the solutions, okay? Well, so yes, at this point you can pause the video and do the exercise, whatever you want. I will continue with the explanation. All right? Then, let's see. The next thing is to preempt a goal. So it happens that you can cancel a goal previously sent to an action server prior to its completion. Yeah? So while an action is taking place, you can cancel it if you want it. Yeah? So maybe you send you call an action that I don't know, that moves the robot, but before it arrives, for any reason you want to stop it, then you can cancel a goal. Yes? Canceling a goal while it's being executed is called preempting a goal. Then yes, here you may need to preempt a goal for many reasons. Like, for instance, the robot went mad about your goal and it is safer to stop it prior to the robot doing some harm, for instance. Yeah? This is a possible case, yes? But preempting a goal means to cancel a goal before it finishes. Cancel an action before it finishes. Then in order to preempt a goal, you use this code here. You call this function, cancel goal. Very easy, very simple. Then you have here exercise 4.7 to test this canceling a goal, this preempting a goal, okay? Well, this is basically the same code we have seen before, but adding this client cancel goal, this call to the cancel goal function. Yeah, so you can try it if you want. I will go through this, but you can test it if you want. You will see it's very simple. Okay. Then, okay, let's do at this point we have seen a lot of things. I have given you a lot of new information. Probably you are thinking this is too much. So let's stop 1 second and do a summary, do a recap. Yeah. So, how does all this work? All this action structure, let's say, work? So, okay, an action, as you have seen previously, as we have seen, an ActionServer message has three parts: the goal, the result, and the feedback. Yes? And each of these parts corresponds to a topic and the type of message. Yes? For instance, in the case we have been working through the notebook, which is the Drone ActionServer, the topic related to the goal was Drone ActionServer goal. Yes? Let's see. Here it is. Drone ActionServer goal. Yes, so this is the topic, this is the goal topic. This is the topic related to the goal. Then the result is the topic related to the result, of course. And the feedback is the topic related to the feedback. Then we can have a look again at this diagram we saw at the beginning of the unit, and you probably didn't understand anything, but now maybe you can see it with other eyes. So whenever an action server is called by an action client, of course, so whenever an action client calls an action server, what is really happening is that this action client, it is sending to the action server a goal through the goal topic. Yes? So through the action client you define, in this case we have seen many examples of action clients, yes? So what is really happening is that this action client is sending a goal to the action server through the goal topic. Sorry, here we have it, through the goal topic. Yes, then when this happens, the action server starts, let's say, it starts doing whatever it has to do. And while this is happening, the action server sends feedback to the action client through, of course, the feedback topic. Yes? So while it is being executed, the action is sending feedback to us through this feedback topic. Then finally, when the action finishes, it sends a result to the action client through the result topic. Yes? So this is basically summarizing what happens when you interact with an action server. Yes? This is basically what happens. So now maybe if you check this diagram, everything starts to make a little bit more sense. Yeah? Of course, we also have here the cancel topic, which, as you may deduce, is used in order to send a cancel message to the action server, in order to stop it, in order to preempt the goal. Yes? You have seen this right now, yes? So this cancel topic is used to preempt the goal, to cancel the goal. And this status topic is used in order to check which is the status of the action server. Yes, so here the action server publishes its status. And you, from the action client, you can check this status, this state, in order to use it, for instance, for doing stuff while the action server is taking place. Yes? So these are all the 5 arrows we have here. Yes? Probably now make more sense for you. I hope it is like this. So let's, we have here a quick exercise we can check. We can do a guided exercise in order to better see this. So let's do it. Excellent. So yeah, let's stop this, and we are going to launch it in the background because we are going to need many web shells for this exercise. So let's launch this in the background, which is done with this ampersand symbol here. Yeah. So we are going to launch this in the background. There we are. Then we are going to execute as well our ROS topic echo here in the goal topic. So let's launch it here. We are going to execute as well an echo of the feedback topic and an echo of the result topic. So there we are. We have 3 echoes, one for the result topic, another one for the feedback topic, and another one for the goal topic. So what we are going to do now is to launch a service action client, sorry. So yeah, because if we don't execute an action client, nothing will happen. Yeah. So in your case, you should execute the exercise 4.6, the action client you created in this exercise. In my case, since I didn't do this exercise, I'm going to use one of the examples I have here. For instance, let's say this one. I'm going to use this example here. So I'm going to execute this action client. There we are. So as you can see, the goal has been published here in the goal topic. The feedback is being published here in the feedback topic, and when the action finishes, the result is published as well in the result topic. Yeah. So when I call the action client, a message is published in the goal topic of the action. Yes. Then, as I've explained it, while the action is taking place, the feedback is being published. In this case, these numbers represent the images. Yes. But this is the feedback that is being published by the ActionServer. And finally, when the action finishes, it publishes its result in the result topic. Yes? In this case, it's as an image as well. Yeah, so this is the data that define the different images. Excellent. So yeah, that's the exercise in order to see how the workflow works between the different topics involved in an action. So yeah, that's it. Yeah, so in the case of this Drone ActionServer, we are working in this unit. The action file is called rdrone.action. This is the file that defines the message. Yes? Then when we compile, if you remember from previous units, from topics and services, when you create a new message, you compile this message in order to be able to use it, right? Then with actions it's the same. In the second part of actions, you will have to create a message and compile it. So when you compile an action message, ROS automatically generates the following types of messages automatically. Yes, it creates the Drone action goal, Drone action feedback, and Drone action result messages. Yes, which are defined in this rdrone.action file. The first part is referred to the goal, the second part is referred to the feedback, and the last part of the message is referred to the result, as we saw previously, if you remember at the beginning of this unit. Yes, so each topic of the ActionServer, we have been checking here, the goal topic, feedback, and result, uses its associated type of message. Yes? So for instance, if we do here a ROS topic info of the Drone ActionServer goal topic, we will see that the type associated is this Drone action goal. Yes? And the same goes for the feedback. ActionServer feedback. So the type associated is Drone action feedback. Yes, and let's do as well for the result. Sorry. There we are. Drone action result. Yes. Then in exercise 4.10, you can check another way to activate an action server. So until now you've seen how to do this by using an ActionClient code. Yes, this Python code, which is the code for an action client, and this is how you were calling the action server, let's say. But as you have learned, at the end what this does is to send a message to the goal topic of the action server. Yes, and that really is what activates the action server. So then you can also call an action server, you can also activate an action server by publishing directly into this goal topic. Yes, so when I executed the action client goal, you saw that what happened really was that the message was published into this goal topic. So if I publish directly a message into this topic, the action server will be activated, in fact. Yes, so let's try this. For instance, let's again activate here the echoes of the feedback topic and the result topic. There we are, to see what goes on. And then here what I'm going to do is to do a ROS topic pub, which is a command you already know, you already use it in the topics unit, which is used in order to publish directly a message into a topic. Yeah, so that's what I'm going to do. And the message, in this case, I want to use, well, the topic I want to publish to is Drone Action Server Goal. Yes, then the message is Drone AS Drone Action Goal. Yeah, you have it here. This is the type of the message: Drone Action Server Drone Action Goal. Then by double clicking in the tab button, the message autocompletes. Yes, so now I can specify here, let's say for instance 5 nanoseconds. Yes, so I will execute this command, and as you can see, feedback starts to publish into the feedback topic, and at the end a result as well. So basically I have called this action server by publishing directly into the goal topic of the action. Yes, so this is another way you can also call an action server. You can also activate an action server. Yeah, excellent. So let's stop this. Yeah, okay, so we are almost done. The last thing we are going to see is the XClient. Yes, so until now you've learned to send goals to an action server using two methods: by creating an action client and script in Python, yes, or what you have seen just now, by publishing directly to the goal topic of the action. Yeah, you have seen these two methods in order to call an action. But there's still another, yes, which is using the ActionClient. The ActionClient basically is a GUI tool, which is provided by ROS, by the ActionLib package, and allows you to interact with an action server in a visual way, in an easy, visual and pleasant way for the user. Yes. So let's use it. For that, you can follow this exercise 4.11. So the first command, which is here, is to launch the ActionServer. We already have it launched here, so you can skip this step if you have the ActionServer already launched. Then I'm going to launch XClient by executing this command here. ROS run actionlib axclient.py, and you have to specify which action server you want to interact with. Yes, in this case it's Parrot Drone action server. So let's execute this command, and now I'm going to open here the graphic tools. There we are, and you will see a window like this one, yes, with a goal section, feedback, and result. Yeah, here you have some buttons, send goal. Okay, so how this works, it's very simple, as you can see. So basically you have here a send goal button, yes, and here you have a variable that you can fill in. So for instance, I can say here, I can insert here a 7, yes, and then click the send goal button. So as you can see, feedback messages start to appear here in the feedback section while the action is taking place, and when it finishes, a message appears in the result section. Yes, and you can read here, goal finished with the status succeeded. So what has just happened here? Well, basically we have published a message into the goal topic. Yes, it's the same, exactly the same you have done here. Here we have published a message into the Parrot Drone action server goal topic, and we stated here the end seconds variable. In this case we set it to 5. Yes, so here you are doing exactly the same, but in a graphical and visual way. Yes, which is much more easy, much more pleasant for users. Yeah, and even you have a button here where you can cancel the goal, you can preempt the goal. Yes, for instance, let's send a new goal. In this case I'm going to set it to 9, let's say. I will send again the goal. Goal is active, feedback keeps appearing, as you can see, and I can, if I want, I can cancel the goal. Yeah, and a message appears here then saying goal finished with the status preempted. So I have preempted the goal. Yeah, so yeah, basically it is the same you have been doing during the whole unit, but in a visual way, which is much more pleasant for the user, and I think it even also helps to clarify some ideas, because being able to visualize them in this way with the goal, the feedback, the result, send goal, cancel goal, everything is presented in a very nice way. So this may help some of you to have a better idea, to understand better how an action is structured and how an action works internally. Yeah, so well, excellent. That's all for this first part of actions. I hope you have learned a lot. I know there are lots of new concepts. Some of them maybe are a little bit complicated, but I hope that you have understood the main ideas of what an action is, how it is structured, how it works internally, and I hope in the following units, even with a project, you can put in practice this new knowledge, so you can learn it better and understand everything better. Yeah, so well, that's all for this first part of action. So I will see you in the part 2, where we are going to be checking the other side of actions. So in this first part we have been working with action clients, with the part that calls the action server. So in this part 2 we are going to see the other side, which is the action server itself. So see you there. Goodbye.